Hi viewers, I welcome you all for this digital system design lecture series. Today we are going to discuss about the topic CMOS Logic, which was in digital logic family. What is CMOS Logic? CMOS logic gates use complementary arrangements of enhancement mode N channel and P channel field effect transistor. Since the initial devices used oxide isolated metal gates, they were called CMOS. CMOS is nothing but what? Complementary metal oxide semiconductor logic. The basic building blocks in CMOS logic circuits are MOS transistor. Why they have chosen this MOS transistor means either it will be very low or very high. So only they have chosen this MOS transistor. This is nothing but the CMOS logic level. Here there are three levels are there: logic 0 level, logic 1 level and undefined logic level. Here the logic 0, that is 0.0 volt to, see here, 0.0 volt to 1.5 volt is said to be logic 0 level or low level. Okay. Similarly, 3.5 to 5 volt is said to be logic 1 level or high level. Similarly, 1.5 volt to 3.5 volt is said to be undefined logic level. This level won't occur. In some rare cases, it will be occurred. During that time, it will be considered as either as logic 0 or else as logic 1. Okay. So next one is MOS transistor. The MOS transistor is a 3-terminal device that acts like a VCR. VCR is nothing but voltage controlled resistance. Suppose if you are giving an input voltage to any one of the terminal means it will control the resistance between the remaining two terminals. Okay. So in CMOS logic circuit, MOS transistor is operated so that the resistance value is always either very low or very high. So this is the reason what I have told you in the previous slide. Okay. Since in CMOS logic, MOS transistor is the basic building block. Okay. Why means it will be either very low or will be very high. Next one is there are two different types of MOS transistors. One is N channel, another one is P channel. This is the symbol of N channel and P channel MOSFET. In this MOSFET, it is having three terminals. The three terminals are drain, source and gate. Now we will discuss about this N channel and P channel MOSFET. N channel MOSFET. NMOS is built over a P substrate. Here the source and drain are made up of N-type material. Here the majority charge carriers are electrons. NMOS is faster than the PMOS because the electrons, which is the majority charge carriers, travel twice the time faster than the holes. It conducts when the voltage is high. You have to remember this point. It conducts. N channel will conduct only when the voltage is high and it does not conduct when the voltage is low. Okay. Next one is P channel MOSFET. Here the PMOS is built over an N substrate. Here the source and drain are made up of P-type material. Here the majority charge carriers are holes. PMOS is slower than the NMOS. Then let's see the last point. You have to remember this one. P channel conducts only when the voltage is low and does not conduct when the voltage is high. Okay. N channel will conduct only when the voltage is high. P channel will conduct only when the voltage is low. Okay. See here in NMOS, here the RDS is nothing but what? Drain source resistance. So the drain source resistance value will be very high. It is in the order of, in NMOS transistor I am talking. Okay. In NMOS transistor, if VGS is equal to 0, then the drain source resistance RDS value will be very high. It is in the order of few mega ohms. If VGS is enough positive, then the drain source resistance value will be very low. Okay, only 2 points. NMOS transistorல VGS ஓட value 0வா இருக்கிறச்ச drain source resistance ஓட value அதிகமா இருக்கும். அதுவே VGS ஓட value enough positive-ஆ that is increase பண்ணும்போது VGS value increase பண்ணும்போது drain source resistance ஓட value வந்து low-வா இருக்கும். This is the concept for NMOS. ஏனா NMOSல என்ன சொல்லிருந்தோம் நம்ம? It will conduct only when the voltage is high. Okay, so only here the VGS value is enough positive. Okay va? Next one is PMOS. In PMOS transistor, if VGS value is equal to 0, then the drain source resistance value is high. PMOS transistor லையும் VGS ஓட value 0வா இருக்கிறச்ச drain source resistance ஓட value high-ஆ இருக்கு. அதுவே VGS ஓட value enough நெகட்டிவா இருக்கும்போது drain source resistance ஓட value வந்து low ஆகுது. ஏன் இங்க வந்து enough நெகட்டிவா இருக்கு? ஏன் அப்படின்னா PMOS transistor வந்து conduct பண்ணும் எப்போ when the voltage is low. Okay, so only here the VGS value is going to enough negative value. During that time the drain source resistance value is getting low. Okay, so in digital IC technology, NMOS and PMOS is used as a switch. In MOS transistor, there are 3 terminals: drain, source and gate. Okay, the gate of the MOS transistor is separated from drain and source by an insulating material with a very high resistance. Suppose if we are applying some input voltage to the gate terminal, means it will create some electric field that enhances the flow of current between source and drain. Okay, due to this field effect only, this MOS transistor is also known as MOSFET. Okay, so in between the source and drain the current will be flows, right? That current will be very small. A small amount of current only flows across that resistance. That current is called as leakage current. That current value will be typically less than 1 microampere. So next one is CMOS inverter. CMOS is nothing but what? Complementary MOSFET. So complementary MOSFET is nothing but it is the combination of P channel MOSFET and N channel MOSFET. See here, this is P channel and this is N channel. So P channel N channel MOSFET ஓட ரெண்டு கேட் டெர்மினலையும் கனெக்ட் பண்ணி அதில் இன்புட் கொடுத்துருக்காங்க. அப்புறம் P சேனலோடைய ட்ரெயின் டெர்மினலையும் N சேனலோடைய ட்ரெயின் டெர்மினலையும் கனெக்ட் பண்ணி அதிலிருந்து அவுட்புட் எடுத்திருக்காங்க. சரிங்களா? P சேனலில் உள்ள சோர்ஸ் டெர்மினலில் சப்ளை கொடுத்துருக்காங்க. அதே மாதிரி N சேனலோடைய சோர்ஸ் டெர்மினலில் வந்து கிரவுண்ட் பண்ணியிருக்காங்க. ஓகேங்களா? இதில் ரெண்டு கண்டிஷன் தான். எப்போ P சேனல் ஆக்டிவாக இருக்கும், எப்போ N சேனல் ஆக்டிவாக இருக்கும். See here, in CMOS inverter, both the N channel and P channel devices are connected in series. The source terminal of the P channel device is connected to source voltage plus VDD. Similarly, the source terminal of the N channel device is connected to the ground. This we have discussed in the previous slide. Okay, so the gate of both the devices are connected together and provided the input. Similarly, the drain of the two channels are connected together and we got the output. Okay, so next one is two conditions as I have told you, right? First condition is when the input is high. Input வந்து high கொடுத்தோன்னா என்ன ஆகும்னா gate source voltage 1 will be equal to 0 volt and Q1 will be goes to off condition. The gate of the Q2 will be equal to VDD. That is nothing but what? positive potential, that is equal to supply voltage. Suppose if VGS2 will be equal to plus VDD means Q2 will goes to on condition. Therefore, output voltage will be equal to 0 volt. Okay. Similarly, when the input is low, so a small concept only have to consider. Okay, when the input is high means N channel will conduct. Okay, when the input is low, P channel is going to conduct. That's all. Similarly, see here VGS2 will be equal to 0 volt. So Q2 is going to off condition. So the gate of the Q1 is at negative potential. So VGS1 will be equal to plus VDD and Q1 is going to on. Therefore, Vout will be equal to plus VDD. Okay. So what I have told you is the simple concept. See here, when high voltage is given means N channel will start conducting. If a voltage is low means, input voltage is low means P channel will conduct. Okay. This is nothing but the characteristics of CMOS. What are all the characteristics? So fan in and fan out. Then power dissipation, noise margin and propagation delay. These are all some of the characteristics of CMOS. What is meant by fan in and fan out? So the number of inputs and outputs connected to the gate, which does not affect the usual performance and does not degrade the voltage. That is nothing but the fan in and fan out values. Okay. Next one is power dissipation. So power dissipation is nothing but it is the product of the voltage which is supplied and current needed to produce the output. Next one is noise margin. It is the amount of noise voltage allowed at the input and it should not affect the output. So the noise margin for a CMOS is 45% of the supply voltage. Next one is propagation delay. It is the time taken for applying the input to the output produced. Okay. It is normally 25 to 150 nanoseconds. These are all the characteristics of CMOS. Next one is advantages and disadvantages. So what are the advantages? Here the power consumption will be less, large fan out capability, high noise immunity and noise margin. Power dissipation is low and fast. It is faster than NMOS. So these are all the advantages of CMOS. What is the main disadvantage? The manufacturing cost is high. Second point, the propagation delay is also higher than TTL and ECL. TTL is nothing but transistor logic and ECL is nothing but emitter coupled logic. Okay. While comparing with these two, the propagation delay is higher in CMOS. So this is the disadvantage. So last one is applications. Applications of CMOS. What are the applications? It is used in analog to digital converter, used in image sensor, amplifiers, static RAM, registers, microchip, microprocessor and microcontrollers, and also it is used in transceivers. It is used in many applications. Okay. So this is what we have covered about the CMOS. Thank you. Thank you for watching.